Hey everyone, Brandon Birchmeier here with RJG at the F.I.P show here in Lyon, France, and just wanted to walk you over our really neat demonstration we have going on here in our booth today. So we're running the mini runner part, and the mini runner is called the mini runner because we run through a miniature runner to make these parts. So this is a 30 thousandths in diameter, or 0.75 millimeters in diameter runner system. It's 3 inches long, and then this part is actually subgated into here. So material flows through this thick sprue, through this small miniature runner, and into the part. And the reason we're running this part is we're highlighting this kind of insane geometry and the closed loop control that now exists with our autonomous features in the CoPilot, which I'll walk you through now. So in order to mold something like this, rather than telling the screw which rate at which to travel, it is a pressure-based process. This is pressure control only. And when you do pressure control only, this mold and this geometry influences the process. And you can see that in our curves here. So what I'm going to do is I'm just going to highlight our velocity curve. And the velocity curve does a really good job of demonstrating this geometry. As I flow through thick sections of the sprue, I generate a lot of speed. In fact, you'll see we're hitting over 260 millimeters per second through the thick sprue. As soon as we reach the choke point in this miniature runner, this velocity drops significantly. In fact, you'll see we're down into 17, 18 millimeters a second. And this sharp decline in velocity is a result of this geometry. When you mold with pressure, the geometry dictates velocity. So this velocity profile is unique to the geometry of the part. So it allows us to flow through this ridiculous geometry without creating flash conditions and creates a closed loop scenario through the part. In fact, the velocity through here is going through that runner system, and into the part here, and then it slows down. And I'm going to pull up the screw so you can see the screw movement. Lots of movement through that sprue, a little movement through the part, and into our hold phase. Okay. So again, this is a pressure-based, constant pressure process that's allowing us to mold these parts, very, very difficult parts. The next thing I want to highlight is our autonomous features we've added to the CoPilot. So this is our autonomous control card, and this is where you set up your pressure profile. So here is the injection pressure set point. You can see it's operating at 23,012 psi right now. What it's doing is actually modulating the injection pressure to maintain our fill time. So our original set point is 23,000. It is now filled a little fast, so now it's at 22,948 psi. Every time it's getting a read on fill time and adjusting the injection pressure accordingly. We are running 100% recycle right now, so as the material varies, it actually is adapting the process to the material. The injection time, so we're injecting for that 23,000 for 2.2 seconds. And this ramp time is how fast we get up to set point. It is the aggressiveness to the ramp up to pressure. Our smart hold feature is how we make the cavity pressure dynamically determine your hold pressure. So based on the plastic pressure seen at end of cavity 1 in my part, I'm reducing my injection pressure by 20% of my cavity pressure. What this means now is that my cavity pressure is driving the machine. The cavity pressure is taking over control. We are matching the cavity pressure profile in the negative by 20%. So if this was 100%, it would be matching this, dropping a 1-to-1 ratio to that cavity sensor. It is now dropping 20% of that. So the drop here you're seeing in pressure is a result of that cavity pressure. And like I mentioned, instead of us, through a decoupled process wanting to, the goal being to copy your cavity pressure curve, here when your cavity pressure curve drives, it always matches. It's the driving factor. It's not an output, it is an input. So you want to get repeatable cavity pressure sensors, smart hold is the way to do that. And finally, in our advanced settings here, start a mold fill. So we are looking for 2,000 psi of plastic pressure. That is starting that fill timer where we are adjusting driving pressure. So that is the start of that fill timer. And then our tuning. Since we're controlling the machine dynamically, we have to have our own PID tuning elements. And what you're seeing here is those PID tuning elements that are set up so the CoPilot can control the machine. Let's back out for a wide shot again. So really wanted to highlight a lot of the new features in the CoPilot. They're coming down the pipe This is our very first public demonstration of the autonomous technology controlling the CoPilot and the CoPilot ultimately controlling the machine. We're really super excited to be debuting it here at the F.I.P show in France, and we're hoping if you're at the show, you stop by and check it out.